Hello students, welcome to Young Cups. We are in the process of finding the correlation between algebraic expressions and formulae. Let's check the next sum. A cuboid has dimensions as shown below. Write an expression in simplified form for its volume. So what is the formula for volume of a cuboid? Volume is length into the breadth into the height. And whatever the answer, you have to write unit cube. Children, for area it's always unit square, and for volume it's always unit cube. So what is the length, children? 4x minus 2. The longest side will always be called as the length. What is the breadth? Breadth is equal to 3x. What is the height? That's the height, how tall it is. 1 upon 2x. What do we have to do? We have to multiply all the three dimensions. So I will go eventually with it. First I will multiply these two. Okay, length into breadth. So I'll write 3x first because I have to multiply it with the whole expression. Okay, which is equal to 3x into 4x. 3 4s are 12. Or rather, I'll write it here. 3 4s are 12. X square. 3 into 2 is 6. It's going to be 6x. Now this is just the area, the length and the breadth. Now I will multiply this entire expression with the height, which is half x. For convenience, half x multiplied by 12x square minus 6x. This has to be multiplied by this. So I multiply half x into 12x square minus half x square into 6x. Alright, so I have straight away taken this minus sign because eventually the answer is going to turn out to be minus only, because there's only one. Whenever there's one negative, the answer will always come negative. So this 2 cancelled with 12 makes it 6. This x and this x, by the rule of indices, it's going to be 6. This has 1 on top. As per the rule of indices, 1. The index can be added up, so it's going to be x cube. 6x cube minus 2 1s are 2 3s are, and multiply these two, 3x square. Now that's what it is for the volume, but this can be further factorized, so you have to take it to the ultimate step. Okay, 3 is the common factor between 3 and this 6, so I bring 3 outside. 3 how much are 6? 2s are 6. But children, it's not only 3 that is going to stand outside. We have x cube out here and x square, so I'll have 3x square outside. Okay, 2x inside minus 1. So that's your expression for the volume of this cuboid. Let's find the total surface area. So what's the formula of total surface area? Twice of length into breadth plus breadth into height plus length into height. That's the formula. So what I'm going to do is, first I'm going to find these values. So the value of length into breadth is equal to, what is the length? 4x minus 2. What is the breadth? I'm going to multiply it by 3x. So this will provide me with the answer. 3 4s are 12, 12x square minus 3 2s are 6 minus 6x. Okay. Breadth into height. Breadth is 3x. Height is half x. My answer is 3x square upon 2. What is the height? Length into height. Length is 4x minus 2. This I will multiply by half x. So this 2, this 4 cancels, becomes 2x. This 2 again with this 2 becomes 1. So now 1x into 2x makes it 2x square minus x. Yeah. Let me explain this part again. Half x 4x minus 2. Okay. This multiplies by this, so it becomes 1 upon 2x into 4x minus 1 upon 2x into 2. 2 1s are 2, 2 2s are 4. So 2x into x makes it 2x square minus this and this gets cancelled, minus 1x. So it's just the same right here. So now, easy to work on the formula. So coming back to this, twice of L into B gives me this one. L into B, this one, gives me this expression which says 12x square minus 6x plus this one gives me 3x square upon 2, and LH gives me 2x square minus x. So let's solve it further. Let the 2 be outside. Let's bring all the x squares together. So I have 12x square. I have plus 3x square plus 2. Then I have plus 2x square. And here I'm left with minus 6x. And this one left behind as minus x. Good to go till now? 2. 12x plus 2x makes it 14x square plus 3x square plus 2 minus 6x and minus x is minus 7x. Yes, children, whenever there are two negatives, you add and let the minus sign remain. Now, let's remove the LCM. You always remove an LCM when you have to add or subtract with a fraction. So 2 into 14 makes it 28x square plus 3x square minus, with this also, this will now 2 into 7 makes it 14x upon 2. I have a common denominator. This 2 outside and this one can be cancelled out. What's my answer now? Can I just continue on this side, please? Falling short of space. So 28x square and 3x square makes it 31x square. And this I copy as it is, which says minus 14x. What's common? between these two? Only x. So x is equal to 31x minus 14. X outside. If I multiply this x by 31x, I get 31x squared. If I multiply this x by 14, I get 14x. So now, for that matter, what's my answer? In the fully factorized form. Alright, what's next for us? The total length of its edges. Okay, so let's draw the edges one by one. Okay, okay. So I have the length. I'll draw two lengths first. Okay, this length is how much? 4x minus 2. This is also 4x minus 2. Okay, alright. So I'll quickly write this down. So we want the total length. So total means addition. 4x minus 2 plus 4x minus 2. Okay, let me draw the breadth. Two breadths coming up, the edges. So it's plus 3x and plus 3x. Okay, let's draw the height. Now this is 3x and this is 3x. Let's draw the height. One height, second height, third height, and fourth height. Each height is half x. So plus half x, I've drawn 4, second half x, third half x, and fourth half x. Again, I will have to draw the length, one length and the second length. So that means another plus 4x minus 2 plus 4x minus 2. Then the width, which is 3x and 3x. So plus 3x plus 3x. Here we go. So total, that means add up all. So 4 plus 4, 8, 9, 10, 11, 12, 13, 14. Half plus half is 1. So 15, 16, 17, 18, 19, 20, 24, 27 and 30. So 30x. Let's count all the, let's add up all the minus 2. So minus 2 plus minus 2 makes it minus 4. Minus 6, and here we go, minus 8. We can also again factorize this. The common factor is 2. So 2, 15, 2 into 15 makes it this 30. X inside, 2 into 4 makes it this 8. That's the answer for the total length of all the edges. That's all for today, students. Thank you and God bless all.